This is Inspiring Design, where unique innovators come together to share their knowledge, share their insight, and keep us up to date with the latest industry trends. And here's your host, Roshan Senanayake.
What's up, listeners? Welcome to Season 4 of Inspiring Design with Roshan Senanayake. This is where the best of the best brands, experts, change makers, and thought leaders come together to share their valuable insights, experience, and knowledge, all centered around the growth sector in advanced manufacturing within Industry 4.0, encompassing various industries, technologies, skills, knowledge, trends, as well as stakeholders, all the while linking it back into education within schools and universities. Today's episode is all about industrial design, one of the most versatile and integrated design disciplines in the modern world today. To speak about this, we're joined by two leading experts, Dr. Tim Williams and Andrew Peterson. Firstly, Dr. Williams is a senior lecturer in industrial design at QUT with extensive professional experience in design leadership roles. Tim understands the value of bringing industry and academia together. This is reflected in his practice in experiential learning, connecting students to industry professions through authentic learning experience such as study tours and industry projects. Joining Tim today is Andrew Peterson. Andrew is a practicing industrial designer and educator. He's been heavily involved as a lecturer and sessional academic across most of QUT's industrial design programs since 2014. He is really passionate about integrating the latest emerging technologies into design workflows, creating human-centered products that can make a real difference. So these are the experts. So without further ado, let's get straight into it. All right, guys, so welcome to Inspiring Design. Now we're here with a bit of a unique recording here with two guests. So who would like to go first? And I'm going to throw the first question at either one of you. You can pick. Tell me a little bit about your background and story.
Okay, well, I'll go first. My name's Tim Williams, and my background is industrial design. So I graduated from University of South Australia in 1988, so I've been around for a while. My career has been split almost 50-50 between working in industry as a designer and working in the education sector. So I've had a fairly wide variety of experiences, from working as a design consultant, also working in as a designer on a payroll in a manufacturing organisation, and also then I've been working for the last 13, which is no longer than that, 15 years or so in the education sector. Mm-hmm. But prior to that, there was a lot of overlap between industry and education.
Yeah, awesome. There you go. A lot of wealth of knowledge coming from there. And what about yourself?
Cool. So Andrew Peterson. I graduated from here at QUT back in 2003, and have since worked as a design consultant. As a local studio here for a number of years. Mm-hmm. If anyone's worked in design at all in Queensland, you'll know Rob Geddes. So worked for years with him, which was fantastic. And following that, set up my own consulting business, Inspired, and have been doing that since then, so the last decade or so, as well as since 2014, found myself roped back into things here at QUT, in the industrial design program here, so doing some tutoring, lecturing of different units, doing some research projects, that sort of stuff. And most recently I'm starting to push away from the client work and more into developing my own products, a bit more of that entrepreneurial aspect.
Awesome. There you go. And I'm not sure if you're aware of this, but this podcast belongs to Inspired Education Australia. So
We're not connected.
yeah, we're not connected, but we're like-minded people. So I love that. And so let's get straight into the main topic of the day, industrial design within an advanced manufacturing context. From your expertise and perspectives, what exactly is industrial design?
Yeah, you promised to explain that in a short sentence, but that's okay. I'll have a go at it. As I was saying earlier, I don't have a concise explanation of industrial design. The best I can say is that it's designing anything that's not buildings, anything that's not clothes, anything that's not furniture, although lots of different disciplines design furniture, so we can do that as well, and not two-dimensional graphics. So it really is anything that's mass-produced or even sometimes not mass-produced, low-volume production, anything that's manufactured generally for consumers. And it's not just products as well, it can also be services. So we can design a service for people or a combination of services and products. So the difficulty of explaining what it is simply the fact that it's an incredibly broad, complex area that has overlaps with other disciplines as well. So engineering, for example, there's an overlap there. As I said, furniture, there's often overlaps with furniture designers. We also may be getting involved in wearable technology, so there's an overlap there with fashion. So there's overlaps with lots of other disciplines. Yeah. So that's why it's very hard to define very briefly. Let's have a try at defining it, Andrew.
The most common response I hear from people when asked this is, "Oh, you design factories."
Oh wow! Okay.
No, that's
I haven't heard that one before.
It comes from the industrial aspect of industrial design.
Yeah, makes sense.
So my response is, well, no, we don't design the factories, but we design the stuff which is made using these industrial processes. Yeah. So typically, those mass manufactured items.
And there you go. And like I mentioned before this recording, I'm in the middle of Steve Jobs' autobiography, one of the, I think, in all-time most creative geniuses that we can see in the modern world. And one of the things he describes industrial designers is literally the coolest job that anyone could do. If he's saying something like that, I think we're in good company. So
it is a lot of fun.
Yeah, it is a lot of fun. And I think the other thing that's really worth pointing out too is that there is a perception that industrial designers just make things look pretty, products look nice. And that's a really, really common misconception, and it's really only a very, very small fraction of what we do. Yes, we do look at aesthetics, that's very important, but it's a very minor part. We also look at things like ergonomics, that's very important, usability. We do a lot of research into user needs, and so that we know that we're designing the right product for the right people.
Empathy mapping would be a very common practice.
Very much so, yeah, that's right. So those sorts of things, it's worthwhile pointing out because there is this perception. And I think perhaps when people look at engineering compared to industrial design, engineering is sort of less focused on the aesthetics of the product than industrial designers are, less focused on the human aspects and the usability than industrial designers are. So I think there's a perception that industrial designers only look at those aesthetic components and then engineers never look at it, but there's obviously overlap.
And I think the two needs to go hand in hand, just like bringing an architect and an engineer together to bring a realization of a building. So
it's like two sides of the same coin, but we're both just looking slightly different viewpoints of the same thing.
Definitely. And at the end of the day, we need to design, taking all of that into account, but design it for manufacture so that the thing can actually be made, which is sort of what we're talking about here today.
Yeah, 100%. Well, that's actually a very good lead on to my next question, which is, given that it's actually a really broad area, it has so many overlaps and goes into so many different things, how do you teach it? Given that we're in a university, that's like you've been experts in that, especially within a QUT context of industrial design. So how does it work from an education point of view?
Well, it's challenging, and another description of industrial design is that it's a mile wide and an inch deep, as opposed to some disciplines that are very focused and more depth. So that creates a challenge because it means that whatever you're teaching, you have to teach that very broad range. But the key thing, I think, really is just to teach students how to be inquisitive and how to problem solve. so that even though there are lots of things that we just aren't able to teach students, we are at least able to teach them how to find out about those things once they've graduated. So I think that's the key important thing. But then on top of that, we have it's very important that we teach students a certain range of key skills. So skills such as sketching, skills such as computer-aided design, skills such as researching products. So there's this range of skills, and then there's obviously knowledge that backs that up. So a range of materials and processes and manufacturing, design for manufacture. So I'm sure I've missed out lots of components there, but
I'm saying that as well. So whilst for the most part we cover a broad spectrum at a shallow depth, there are aspects such as injection molding, which are very common for industrial designers to end up designing products that are injection molded, and it's a bit more of a complicated process out there compared to some of the others, and so we do focus on some of those areas in greater depth, but often it's still industry may find us lacking in some of these different areas, but as Tim was saying, the intent is to develop students that are well-rounded and can explore and discover the depth as they need to, rather than the expectation that they all come out knowing this one thing really well, because they'll go out and they'll get a job and they'll for sure be doing something different to what they've been taught, and you don't want to be stuck in a position where I don't know how to do this, I'm stuck, what do I do? It's I can absolutely tackle that problem for you, I know how to go about finding the answer.
So I think if I'm hearing you right, it's the problem solving, critical thinking, creative approaches to those kinds of any context really. So how do you then bring in, so one of the very common questions that the listeners that we usually get from teachers and students at a high school level is the software that gets used. So you mentioned computer-aided design. What are the foundational tools that's running industrial design? Like, what do you guys use?
Well, there is a range of different software packages that you can use. Computer-aided design is the key thing. So three-dimensional, often parametric-based 3D modelers. We use SolidWorks here particularly, but Fusion 360 is also used, and in industry there is a vast variety of CATIA, ProEngineer, Creo, so on and so on.
They're all largely similar as well. So, and I learned SolidWorks and Rhino and AutoCAD and different ones at uni. Went out, got a job, and was using Pro-E Wildfire 2, and then transitioned from there into Fusion and other software. These days, jumping into Gravity Sketch and VR. So that's an avenue we're moving into here at the moment as well. But there's so many different options. From an earlier stage of software, so from the sketching side of things, we do a lot of analog stuff, but we also do see a lot of digital work these days. And so on the iPad, Procreate or Autodesk Sketchbook, very common tools. It's really anything that can help progress efficiently your design work. And then into the CAD side of things, design for manufacture aspects. So.
Perfect. Well, and I'm very glad to hear that you mentioned Gravity Sketch in VR. So we're kind of exploring these new sectors with these new tools coming in. I personally see the way Gravity Sketch is when CAD first came out. Like if we're thinking about the foundation of AutoCAD when it first released, we're still trying to find our feet.
What version did you use?
Which version of AutoCAD? The first one? 2. AutoCAD version 2.
Oh, wow. Okay, there you go.
That was on. It was DOS-based, didn't pre-Windows.
Right.
That was 88, I think.
That would have been a completely different way of
thinking. That's right. And then I was lucky, actually. I saw SolidWorks coming in. The company I worked for was one of the first companies in Australia to purchase SolidWorks in SolidWorks version 97, I think it was. So I've been using SolidWorks since, 25 years.
Wow.
So it's been around for a long time. So people tend to think of CAD as being this new thing that's come out. But from my perspective, it's not that new. 3D printing is another example where I think I got my first 3D printed model back nearly 30 years ago. So again, it's not new, but
it's become more mainstream.
Exactly.
Yes.
So what's happened, I think, is it's got to the point where it's found its niche. It's 3D printing has got to the point where it's cost effective enough. Machines have become so much cheaper and so much more effective, and there's a much wider range of materials and so on. So I think that's happened, and I think also with CAD has become really mainstream, 100% mainstream. No one would design. Well, there are very few design projects where you're producing a product that you wouldn't use CAD. And 3D printing as a rapid prototyping technique, which is what it used to be, has always been used and continues to be used. But of course now we're going more into additive manufacture, so we're using it as a manufacturing tool. But that's just in the infancy. So we haven't really got to that point where it is mainstream.
Just on the CAD side, one thing I'd add to it as well is, like, I'm aware a lot of schools have traditionally used Inventor, for example, and that we don't typically use Inventor here at QT anyway for industrial design purposes, but it is very similar to SolidWorks, to Fusion and the other ones. And ultimately, the primary difference between them is where the buttons are located. The same process behind it.
And the same approach, same thinking is involved.
The workflows are very similar. Maybe you click something in a slightly different order. But once you know one, you pick up the next one much faster. You pick up the third one even faster. And so that's also something that we try to get across to students here, is that you'll probably learn these and go get a job, and you might be specialising in a particular industry and they use CATIA or something different. But if you're aware of the process, the workflows behind it, it's very transferable.
I think that's music to ears for many teachers. Currently in 2022, we're going through these teacher shortages at a high school level everywhere in Australia and some other countries globally as well. And design educators are even rarer to find, and therefore all of these non-design background professionals are coming into that context. So their method of thinking is very different. Recently we had a botanist that was part of their design, and we were walking through Fusion 360. So their approach to thinking was very different, simply because of their mindset of what they've worked for. So I'm glad that you shared that about the I think different approach in looking at the software rather than just looking at things from that particular window. So where do you think, all of these tech things are cool, where do you think lo-fi prototyping, and actually can you guys explain what is lo-fi prototyping, hi-fi protyping in your knowledge? This is a common question and it just came to my head.
Absolutely. I've seen a description that was put out of all the different types of prototypes that you can get. I think there's about 20 categorized, and so you can break it down to a lot of different ways. But the reality is that you generally start off with a prototype to test out. So whenever you make a prototype, it's really important that the prototype is there to do something, to test something. So normally to start off with, you'll just be testing out maybe the size, volume or shape of something, maybe a hand grip or something very simple. So being lo-fi means that you want to get something really quick that's just going to test out one little aspect. And then as you progress through the design process, you'll refine that down to something a little to more accurate, with a lot more detail in it, and then that becomes the hi-fi prototype.
So you can start with paper or cardboard,
100%.
Polystyrene foam, your high-density foams, that sort of stuff, something you can carve and hack
anything
into
nice
quickly.
And quick.
And as Tim was saying, it's that rapid test, iteration, develop something, get an understanding of the shape and size, and but then use cardboard to do cross sections of mechanisms and how things are working, and so you're looking at the functional aspects then, and then you start to combine them into your higher level ones where you're integrating the mechanisms into the forms and getting your really nice aesthetic finishes and everything. As Tim said, there's about 20 different types of models you might do, but they each communicate something, and that's the core thing to prototyping. Is it's a communication tool, especially up until the point where you have the final design. 3D printers are really making prototyping often skip a number of those early stages.
And you go straight to high
so,
fidelity.
people will go straight to, I'll do a CAD model and I'll print it. But it still takes time to print. And in that time, you could have still explored a whole bunch of different variations using paper or cardboard and come up with a better solution. So yes, you can do it quickly, but yeah.
Interesting. And obviously, given how much of the lifespan of computer-aided design has been around, we're almost now adding a whole set of new tools with, machine learning, AI coming into play, VR designs, and, apps like Gravity Sketch being in its early days type thing. Where do you think we'll be in the next 10, 20 years as an industrial designer? What do you think you'll be doing, let's say, in 2040?
Yeah.
Well, I think
Retired.
Retirement, yes.
Yeah, that'd be nice. Look, I think definitely AI is going to have a big impact, and there will be tools that will help us design.
Will it replace the industrial designer, do you think?
I don't think so.
Okay, why?
I really don't think so. So the reason why is because I think probably the two hardest things for AI to do is empathy and creativity. So we know that. Creativity, there's a difference between creativity and there's a difference between just coming up with something new and coming up with something that's new and useful for people. And I think in order to make something useful, you need to have empathy. You need to understand people, not just have observed them and then think and that's all a computer can do really, is it can observe, it can be fed information. Yeah. But can it really understand, what it's like to get on a train?
There's a level of intuition that can't be replaced. Yeah,
I think that's really, really hard to do, and maybe at some point it will get to that point. But I think it'll be a very long time before we get to that point. So, but I think tools, absolutely. There's going to be some fantastic tools that will really help us, and to be honest, I don't know what they're going to be. It's going to be interesting to see what happens and what develops in this space. But like in every profession, I think there will be tools, AI tools, that will just help us do our job better. There might be tools that, like DALI, that will just help spark an idea and it'll help us along the creativity path. But I don't think they're going to do the job for us anytime soon.
I think there'll be a mix of tools, and the common thing is fear of, I won't have a job because technology is going to do away with it. But really it's a tool. It's adapting and improving what we can do at the moment. And so instead of taking weeks or months to design, go through hundreds of iterations, it's like, okay, well, maybe we'll become a bit more of a wordsmith and have to have that knowledge of history that we can phrase our text prompts in an appropriate way to get the AIs to come up with the best visual results, and it'll come up with a wall full of hundreds of ideas that we can effectively be a design director, go through the process and say, okay, I like this aspect, put those together, try this one in, and it speeds up the flow of the design process and lets us explore more than we could traditionally have. So it's actually making things better. That's where I want to see it go, and then linking in with turning those 2D conceptual images into your 3D models that can be manufactured using a specific process. And we already see some of those tools coming in through even like Fusion with the generative modeling. You can specify something to be injection moldable and lightweight and super strong, and it'll iterate the different things. But at the moment, it doesn't, as Tim was saying, have that idea of usability or of empathy. And so is it going to create something the user actually wants and desires? And so especially until we get those links happening, there's definitely a huge role for the designer in that process, which to me is really exciting. And
100%.
Just last week I was playing around with DALI, created some furniture designs in DALI, dropped it into Gravity Sketch, and 20 minutes later had the chair in 3D sitting there. But the design itself,
Yeah.
like looking from a designer perspective, is like, that's not going to be a comfortable chair.
Yeah,
It's not
yeah.
really that functional,
Yeah.
and there's going to need to be a lot more thought go into it before I could manufacture this chair.
Yeah.
So there's a few missing links yet. But
Yeah, 100%. And I think the way one of the things that I constantly go back to, and when you were describing it, what came to my mind was when Tony Stark from Marvel was actually designing that first prototype
Yep.
of his suit
Yep.
in a cave, and it's actually put together again in a very MVP context, and then refined and 3D printed and polished up. CAD, AI, all of those systems coming into play. So that's, I think, the very cool part. Now, you mentioned the word automation and job losses, and I think that's the part that I wanted to explore a bit more, because how do you see this next iteration of where is the job losses happening with the adoption of tech?
oftentimes it might be the low end of the
Everyday tasks.
the everyday tasks
Mm-hmm.
where jobs are lost because they're easy to automate.
Yeah.
The thing is, oftentimes those are tasks that people don't want to be doing anyway, and we're better suited to the more creative things or those higher level tasks. So they're often the ones that are most at risk.
Yeah.
But sometimes they are ones that people just want to do. So you don't necessarily rule out all those jobs. People will still want to do them at times.
Yeah.
The automation aspect, I guess, and the job losses, one comes to mind, and I think you've done a podcast on it recently with Watkins Steel. And so the idea is that, okay, well, we've got new tools, we can actually upskill a lot of our workers to these new tools that we're using.
Yeah.
And so it's not so much about job loss, but
Evolution.
enhancing that evolution of the jobs, giving people that opportunity to increase their skill sets and do more interesting things, leads to better wages for them as well, and better opportunities for the companies behind it. So I think it's a mindset as much as anything, is to be thinking about how we can not just kill off a whole bunch of jobs, but we create new ones.
Where's the next iteration?
Yeah, and move into those spaces.
And I think that's been something throughout history where the Luddites thought that would be the end of the clothing industry once the automatic weaving machines came out. That didn't happen, and I remember there was discussion about, well, it's going to be the end of industrial design when CAD takes over. Well, CAD hasn't taken over; it's just become a tool that we've used.
Yeah.
But I think one of the really interesting possibilities is that as we adopt things like 3D printing or additive manufacture, it gives us an opportunity to create mass customization. So with mass customization, the one thing that we're going to need is more designers to design the things that are going to be mass customized. So in many ways, some of this technology will actually creates more jobs, or has the potential to create more jobs, whilst other taking away, as Andrew was saying, some of the drudgery that goes along with the job as well. So in many ways, I think it's just going to improve and possibly even increase the demand for industrial design.
Yeah.
And then who knows what's around the corner.
Digital cameras didn't replace the
Photographer. Can't
but-
replace that eye.
No.
Yeah.
But it opened up opportunities for a larger group of people to be involved at some level of photography.
Yeah. And I think that mass customization is the key there, because that's how Industry 5.0 is kind of defined almost very commonly. So thinking about the requirement for mass customization, the center of it is actually the empathy, the intuition, the creativity. How do you actually mold something for a particular person, but done at a massive scale with all of this cool tech? So that's, I think, where the iteration of the next wave of jobs and how we work is changing. So where do you think the key technologies that'll drive industrial design over the next decades, what do you think you will see? What's here to stay? Similar to CAD? What are your thoughts?
Well, this is a difficult one, isn't it? It's future casting. Look, I definitely CAD CAD is here to stay, and I think Andrew mentioned this before. One of the interesting things will be when CAD evolves a little bit further to take away some of the complexity of how to design an injection molded part, for example, and it's very close to that. And I think what's really interesting will be interacting with CAD in a more tangible way, or not tangible, but immersive way, such as Gravity Sketch, which is essentially CAD. It's just, but it's full scale. And I think once those tools develop, and the interesting thing about them, I think, like VR has been around for a long time. I think it's 70s, if memory, something like that. So it's not new. It's not a new technology, but it's just got to the point where the hardware and the software have evolved enough to make it useful. And I think now it's got to that point, and I think it still has a long way to go. I mean, there's a lot that Gravity Sketch is sort of the only option really at the moment, and it still has some limitations. So I think there'll be other offerings that will come up which will make that space really, really interesting. And I think this way of interacting with, and when the hardware gets a little bit more usable as well, because there's only so much time you can spend with one of these things stuck in front of your face. So that will have to improve, but it will improve like all other technologies do, and it'll become refined enough so that it's very usable. Combine that with AI as well, and we could really see some interesting things happening. But who knows where that's going to take us.
Going back to your Tony Stark idea of so not only VR but your AR, your overlays of maybe
whether
you're
it's
doing
a tabletop,
maybe you're doing a quick foam mock-up of something, and you're overlaying some visuals of it, creating a scanned model of it simultaneously that you can then sculpt in CAD, that you run through an AI generator that develops some iterations for you and automatically sends to your 3D printer and runs that through. And from your manufacturing perspective, put your glasses on and you've got your digital twins of your factory set up, where you can tell where everything else is in the factory that's coming down the pipeline towards you. It's giving you instructions on where to weld or what bit fits with what other bit, or where some missing tool is. It's like, where's the screwdriver? Oh, it's over that way. So there'll be a lot of those sorts of abilities come through.
Definitely, and I think that's where even going back to the Tony Stark thing, his material knowledge, his worldly physics, chemistry knowledge applied to the design process he was the one running it. The only difference between how we work and what we see on the movie screen was he was just telling an AI system to actually go through the rendering and do those, production heavy things that we spend hours and hours doing in front of the screen. So I think that's where I think the cool things are yet to come even. That's where this exciting industry can take us, I think.
The mass customization aspect as well that we're talking about, it's in a way ideal for the Australian market, because globally we are very small in Australia, and so in some ways we've got left behind in the manufacturing area for a while, and part of that is just because we don't have the number of people to make it worthwhile scaling up huge factories and automated assembly lines and everything like that for one type of product producing countless millions of. But the idea of the Industry 4.0 and 5.0 of that mass customization and being able to have smart machines that are connected to each other that you can rapidly change and do something unique for each different one, design a pair of shoes that adjust based on the person's actual foot and where they put pressure on things.
And that's actually exactly the last episode just before yours. iOrthotics here in Queensland, they're doing the exact same thing, but roughly doing 35,000 customizable orthotics for each individual different person. So that was incredible.
And Adidas are using tech in some of their shoes these days, but they're not quite customizing them individually yet. But that would be an obvious next step. And it's the sort of thing which in Australia, in the smaller market, for us is ideal, because we can go through a lot of these processes where it's almost going back to the artisan approach, but in a mass
method with tech.
Yes.
Makes sense.
And so kind of almost skip a generation of industry and really take advantage of the smart interconnected nature of things, but bringing the human element back into it.
And I think this is where this a lot of people, I think, aren't aware of how much of a central role the industrial designer has in between all of these things. So if you were to give some advice for students who might be listening, they're thinking about exploring, they like design, but they're not 100% sure at a high school level, what's your advice for the students? Something good's going to come now.
One of the I think we mentioned this before. I think it's really worth probably mentioning at this point, is that to do CAD right, it's really important to get the basics right, even though they're a little bit boring, and it's following the right workflow. And so, and it probably doesn't really address your question, but it's related, and I think it's worth pointing out that getting those basics right and making sure that you follow an effective and good workflow, it makes your life easier. It's really good to get into good habits as early on as possible. And there's always this enthusiasm to sort of leap forward and just jump in and get something happening. But taking a step back and taking your time is well worth it. And the design, and that actually applies to the whole design process, not just CAD. Because there's always this temptation just to go, I just want to get this thing out there and just like leap straight into CAD and make something. And that's part of everyone. Everyone wants to do that, but when you take your time and you actually take your time to go through various iterations and try and come up with as many ideas as possible, that's a much better design process than just leaping at the first idea that you come up with. So that's really important. So so I think there are some things. I think the key message I'd say to students would be, listen to your teachers, listen to the process. The process is the most important thing. Follow that process, and it might seem a little laborious, but it'll give you the best results, and the results are really what you're after. So, and try and resist that temptation to just jump to a solution.
It's a big difference often between an inventor and a designer, is that the inventor will often latch onto an idea and just go straight to the solution, or they might accidentally go through a bit of a process, but the designer is someone who does follow that process. I mean, here at QT we were mostly following the double diamond approach, probably familiar with. There's a whole bunch of different methods or approaches out there. But following that approach, that methodology is really important.
The double diamond is now part of the Australian curriculum as well, cool. So it is common in the context of high school level as well. So it's aligned with their tertiary education that's going hand in hand as well. So it's one of those things that we're innately wired to go and problem solve, because that's what humans do. We got to problem solve because we've got a problem. So it's the difference between becoming a designer and waiting for that, going through failure, going through the iterations, but also spending the time to getting to know who the person is, who the user, who's the endpoint. Mapping those processes, spending time on those things is very important. So awesome. Any other advice for students? Because I feel like there's a lot. Maybe this is some advice not necessarily for students, but for the outside world. I think maybe for students to try and educate the rest of the world about design, industrial design we'll talk about. I don't know about other disciplines so much. But the design is not a linear process. And one of the things that I love the double diamond process, because it puts the emphasis on the research side, which is really important. But one of the problems with it is that it tends to denote a linear process where you start at one end and you work your way to the other end. And design is not like that. It's messy, and you have to be prepared that sometimes you'll go down some path that's going to take you nowhere. You have to go back, and every time you go back though, you learn something new and it becomes better. So having a sort of this sort of iterative circular process that's all over the place, it might seem confusing, and a lot of other people from other disciplines I think most other disciplines in the world tend to work on a more linear process. So I think a lot of people really struggle to see the design process as being this messy process. But I guess we just need to educate the rest of the world that design does what design does, and the results that we get are from not following a linear process, from following the process that works best. And we know over many, many years that sort of messy process is actually the way it works. But to conceptualize it, the double diamond works really well because it shows how we... And I think you're 100% nail on the head. When you actually search design thinking models, just as a quick Google search, you'll get thousands of different visual models. And that's the same design approach, just fitted to different contexts of how people visually represent it. So this is something we constantly try and hammer in our workshops. So I'm very glad to hear it.
I'd add in for students to follow your passions as well. Even here at university, once you've left school, you've chosen to do, say, industrial design, you've obviously got an interest in it, but there's still a big difference between the students who are passionate about it, who live and breathe design, who are interested in how things work, who when something breaks, they pull it apart and want to figure out why and how this thing works. They're the ones that you can see by the end of university, they're the ones that are going to change the world afterwards. Yes, you can be a designer that just knows how to do stuff, but unless you're passionate about it, you're going to walk away jaded within a few years because it's just not worth it. So, follow your passions.
Yeah, and I think, again, going back to Steve Jobs, one of the quotes came to my mind while you were saying that was he was constantly saying, if you're working for Apple, if you're working for my team, we're creating insanely awesome products. We're not here to make money. We're here to create insanely awesome products. Keep saying that.
Don't go into it for the money. It's not really there.
There you go.
Be inquisitive is the other thing I'd say. Be inquisitive about everything. Every time you look at anything, just think to yourself, well, how was that made? Why was it made that way?
How's that coming together?
What was the designer thinking when they were doing that? And with that, you might not necessarily have the answers, but at least that's how you should look at the world. And design great products. I mean, that's what it's all about. Design something fantastic. And try and convey that. So the trouble is that if you go into a meeting with a whole bunch of other people, there might be accountants there might be the managing director of a company and whatever. They're there to make money. That's their job. Their job is to make money. Yep. Your job is to make awesome products.
There you go.
The two things are not necessarily. Well, they're compatible. Obviously, if you have great products, you'll probably make lots of money. Yep. But the way of making a great product is not necessarily the most efficient way of making money.
Correct.
So there's a little bit of friction there sometimes.
Yeah.
And don't expect to be spoon-fed everything either.
Yeah.
That's where the curiosity and inquisitive.
Yeah, exactly. And as teachers, you don't need to know the answers to everything either.
That's literally the next question I was going to ask you. What's the advice for the teachers? Because that's something you literally took the words out of my mouth. What's your advice for teachers? Because this is something we constantly tell them. You don't need to know exactly what the answers are.
The thing is, you can't.
No.
It's too much.
So how do you handle that?
My advice really is to as I said, the process is really important. Stick with the process. I know there's a quote from IDEO from Tim Brown, who said something along the lines of just believe in the process and you will get results. Even when you're doing something you think there's no way we can get anything meaningful out of this, just follow the process, trust in the process, and it will take you to the end. And I think there's a lot to be said for that. So for teachers, don't spoon feed. Just let's just show them what the process is, but then let them go.
There's a lot of great resources out there that students can follow up on their own as well. And it's in some ways it's often what I'm doing here is showing here's some places you can go to find out this information. I don't have all the answers. It's all there. Yeah. I haven't needed to find the answer.
You haven't explored that particular problem. Yes.
But if it was me, then this is somewhere I would go to find an answer for that. Or these days, Google, YouTube, fantastic resources. And when I went through uni, I was learning 3D Studio Max with two 800-page textbooks sitting on my lap, trying to find keywords in there to figure out how to do something. And now it's like, okay, well, if I want to do something like that, I'll just jump on YouTube or LinkedIn Learning or one of those tools and type in a couple of keywords, and there'll be some 10-year-old kid who can explain to me how to do that particular thing. I haven't needed to know until now, but that's
looking for the answers.
It's looking for the answers and how to find the answers is sort of the key things that I would be trying to get across rather than being an expert in everything. But
Yeah, and also there's no right or wrong when it comes to design. That's one of the interesting things about design. There's no right or wrong. There's only better or worse. And better or worse is subjective.
Yeah.
So I mean, you can get it right or wrong. If something doesn't work, obviously, it's wrong.
Yeah.
But generally, if it fits the criteria, fits the brief, then it's
how well is it executed?
The question is how well does it do that, and does it go beyond just what the brief is trying to get you to do? You know, can it do something further? That's when it becomes really interesting when you start pushing the boundaries.
Yeah, and that whole idea you started off talking about, Tim, of industrial design going beyond the physical product to broader systems thinking, and then even expanding out into business opportunities or different areas. I mean, we're not trained as in business or trained in some of these other areas, but our approach and the process, if we can start to be thinking about those other areas with a design mindset, it opens up a lot of opportunities, which is what then leads into a bit more of that entrepreneurial aspect, which is where I'm leading into these days.
Yeah, and it actually reminds me of a case study we did with a state school in Sunshine Coast, where the teachers were guided with this kind of thing, and they broke the 14-year same project, the factory mentality that they've been doing for the last 14 years. All they did was allow the students to find their own problem. But there were so many industrial designers, now that I think about it, there were girls making different jewelry items that were designed towards climate action. There were fabric printed t-shirts. There were irrigation systems. There were IVD specialist game designs. And we were blown away by it just by looking at these different viewpoints coming together, and they were all kind of aligned with industrial design, otherwise smack bang in the middle of it, and they came up with those ideas themselves, and they were just so surprised. So that's great.
I mean, setting a brief, for example, don't necessarily go into it with a preconceived idea of you're designing a spice rack. What you're doing is break it down to your basic principles of why we're designing a spice rack. Well, we need to organise these things. And so
held in the why.
Your job is to make it easier to access the correct spice. And
give them a different twist on the brief.
Perhaps instead of a physical spice rack, it becomes the label on top of the container so you can see it easier. Or there's different ways to explore that.
There you go. Coming from a student who's actually gone and done the spice rack when they were in high school. There you go. Love it. So, unfortunately, I feel like we can talk about this for days. But for the purpose of the episode, we've come towards the end. So if they do want to reach out to you or get in touch with you, what's the best method of contact?
Just via email, I think. Just email us at QUT. I think you'll probably put the email address somewhere. It's accessible. But we're happy to field any questions about industrial design.
Awesome.
Absolutely.
We'll definitely drop those details in the show notes, and you guys can get in touch with both the speakers today. So one random question that I usually ask, and this could be honestly anything. It comes to me on the moment, but I feel like I've been talking about movies, Steve Jobs and everything. What's your favorite movie from an industrial design perspective that's just been so awesome?
Minority Report, I reckon.
Minority Report, interesting. Why?
Just the interaction, design of how to interact with screens, and the following of the advertising. Just because that's technology which is really. It's nearly here.
We're almost there.
We're almost there. So it's really, I think, really good future casting because it's believable. It's nearly here, but not quite. And I think that's really compelling.
Yeah. What about you? Can't say Iron Man.
So many different movies. Can't say Iron Man.
Can't say Iron Man.
I do love his approach to stuff, and some of the other Marvel movies as well in that space as well. The Wakanda tech and all that sort of side
absolutely.
of things. It's just awesome. And it's like
the way they're doing things.
And we've got guys that have come through. I think you've interviewed Ben as well, who's come through and actually gone and done work in Marvel.
Yeah, he's working on Avatar 2 right now, so it's insane things. So I think that's where the cool part is, like the endless possibilities with this exciting field. So thank you so much, gentlemen. It's been an absolute pleasure. We can talk about it for days, but I think already the listeners have so much, so really appreciate it.
Yep, thanks, Russia.
That's it for today's episode. Now it's time to take action and build on the learnings to get inspired. First up, jump onto rashansenanayaka.com/podcast and check out the show notes, links, and other relevant learning materials from this amazing episode. Next, if you learned something new today, click that subscribe button and set yourself up to receive live notifications on future episodes, as well as more opportunities to learn from our amazing guests, brands, and speakers. Last but not least, it's time to have your say. Join the conversation and share your thoughts and feedback on today's episode with a review, all while joining many others with a 5-star rating for Inspiring Design with Rashan Senanayaka. Till next time.